Natural deduction system for a structured deduction from a set of assumptions based on rules specific to the logical connectives. The way of proving that an argument is valid to break it down into several steps. That is, to show that everyone can conclude some more obvious and valid arguments. Deduction is a sequence of formulas formed by obeying some fixed rules. For proving theorems in mathematics or any other science, deduction is a simplified model. Deductions are also called formal proofs. If a deduction is correct, it is easy to check. Even a computer can check correctness. The difficulty is just in finding the deduction. The deduction is a calculus for reasoning about proportions. It is an expensive to test whether a proportion is a tautology by testing every possible truth assignment. That is, there are exponentially many. The deductive system, which allow us to construct proofs of tautologies in a step-by-step possible rules, which is known as natural deduction. There is a collection of proof rules in a natural deduction that allows us to infer new sentences logically follow from existing sentences or allow us to draw a conclusion given a certain arrangement of premises. These proof rules allow us to infer new formulas from other formulas. Just suppose there is a set of sentences that is pi 1, pi 2, etc. to pi n are called premises, and another sentence's formula which is represented as psi called as conclusion. By applying proof rules to the premises, it hopes to get some more formulas, and by applying more proof rules to those formulas, it hopes to eventually obtain the conclusion. This intention is denoted as pi 1, pi 2, etc. to pi n, which implies to the conclusion psi. This expression or notation is called as sequent. A sequent is a valid if a proof that is built by a proof rules can be found. In a logic, it is used to check lowercase letters used to stand for formulas and uppercase letters used a set of formulas. Natural deduction rules. Here are some natural deduction rules which are the above line are called as premises, whereas proportional below the line is called conclusion. Both the premises and conclusion may contain meta variables representing arbitrary proportions. The meta variables are replaced consistently with the appropriate kind of proportion when an inference rule is used as part of proof. Most of the deduction rules come one of the two flavors, introduction or elimination. Introduction rule introduce the use of a logical operator, whereas elimination rules eliminate the use of a logical operator. The name of the rule is written on the right hand side of a rule, which is helpful when reading proofs. There are some introduction rules and elimination rules for each logical connective. There is also a concept of assumptions such as introduction and cancellation of assumptions. An assumption can be reused many times before its cancellation. An assumption is cancelled only when the rules allow it to be, but not obligation. Rules for natural deduction. Here is the rules for conjunction, which denotes a pi and psi, which have an introduction and also a conclusion separately. Note, the premises of rule are shown above the line. The conclusion is below the line. The right of the line, conjunction I, is the name of a proof rule and read as an introduction. Since we have introduced conjunction in the conclusion where there were none in the premises, there are two rules to eliminate it. The rules are called elimination and elimination. The rule conjunction E1 says if you have a proof of pi conjunction psi, then you can get a proof of psi by applying this rule. Rule 2. Conjunction E2 says if you have a proof of psi conjunction pi, then you can get a proof of psi by applying this rule. Here is an example that P conjunction Q or entailment Q conjunction R is valid. P conjunction Q is a premise 1, R is a premise 2, Q conjunction E2 premise 1